Congratulations on making it to the last set of videos on the review packet for the final. Let's get started. A straight stretch of mountain highway drops at a grade of 9 degrees. If you drive a distance of 15 miles along this road, how far have you descended vertically? Well, remember I always told you to draw that Z? That helps me for sure. And if there's 9 degrees for the descend, there's also 9 degrees for the ascend. And we're talking about the road being in the middle, and that would be 15 miles long. And you could put your vertical line on the left or the right. I'm just going to put it on the right. We're trying to figure out how far we've descended vertically. So I'm going to call that Y because Y stands for up and down. Now I'm going to go ahead and label my sides. Here I've got across from my 9 degrees is going to be my opposite. And of course across from my right angle is going to be my hypotenuse. So this is going to be an O and an H, and that's going to be sine. So I'm going to have sine of 9 degrees equals opposite over hypotenuse, in this case Y over 15. I'm going to multiply by 15 on both sides to get rid of that denominator. So the 15's cancel, and I'm left with just plain old Y on this side is equal to 15 sine of 9 degrees. Now make sure you click mode on your calculator. That's right by your blue button to the right. And make sure you're in degrees. And when you do 15 sine 9 in your calculator, you get 2.35 is equal to Y. And that's going to be answering the question, 2.35 miles that you've descended. All right, let's take a look at the next one. This one's definitely a longer problem. We usually did this problem with like a tree that, has been pushed over, like, I forget what the other one was. But we've seen this problem quite a few times. The Eiffel Tower is inclined at an angle of 8 degrees from vertical after a big windstorm. So drawing that, so here's my vertical right here, and it's inclined 8 degrees from vertical. So that's your 8 degrees right there. From a point 150 feet from the base of the tower, with the tower leaning towards the observer, the angle of elevation is measured from the ground to the top of the tree. Oops, it shouldn't be tree, I copied and pasted. Change that for the actual. Should be the tower, is 47 degrees. Find how high the top of the Eiffel Tower is above the ground. So it's saying from a point 150 feet from the base of the tower. So we're talking about that distance being 150 feet. We're saying that there's an observer right here that's looking up at the top of the Eiffel Tower. And they see that at an angle of elevation of 47 degrees. Okay. Find how high the top of the Eiffel Tower is above the ground. So the actual thing that we're looking for is the height of the Eiffel Tower, and height always makes a right angle to the ground, so we're looking for that H right there. All right, let me make this a little bit clearer. 47 degrees. All right, so now we need to start filling in this triangle, and we know that if this is a right angle right here, which it is because it's the vertical line, we know that we can do 90 minus 8 degrees and we get 82 degrees for this. Okay, and then you see that we have, okay, that didn't work. You see that we have, can I change colors here? Yeah. We have a triangle right here with angles 82 degrees and 47 degrees. So I add those two angles up and then I subtract it from 180. And I get that the angle up top here is a 51 degrees. And that angle is for the entire angle right here. So really what I have is a triangle with, this is not to scale, but 82, 51, 47, and I know that this is 150 feet. So what I'm going to do now is I'm going to use the law of sines to find one of the sides of the triangle, and it totally doesn't matter. You could find either this side right here or this side right here, but I'm just going to stick to doing this one right here just because I want to. And so I'm looking for that side, so I'm going to put a Z there. And I know law of sines, I need to have 3 of the 4. So I've got an angle right here with the side opposite, and then I have an angle and I'm looking for the side opposite it. So that's the perfect setup for law sines. So I'm going to do sine of 51 divided by 150. You can see those are the two I circled up above right here. And that's going to be divided by sine of 82 over z. Okay, so what we're going to do here is we're going to multiply, or I don't know, should we cross multiply? I think so. Let's cross multiply. So that's going to give me, let's come right up here, that's going to give me z times sine of 51 is equal to 150 sine of 82. And just make sure you put that constant in the front. If you put it at the end, just make sure you close your parentheses about after your angle, or else it'll be taking sine of that value, which you don't want. So now to solve for z, we're going to divide by sine of 51 on both sides. I always want to do that, the thing that's attached to the z. So now I'm just left with z equals, and then 150 sine 82, close your parentheses here, and then divide it by sine of 51, and I do get z is equal to 191.14. So I'm going to go back up here, and I'm going to mark this as 191.14. Okay. Now I'm going to use a different color here to highlight the fact that we're going to just focus on this triangle right here. Okay, and then pulling that off to the side, I get 191.14. We just had that, a 47 degrees, a right angle, and h, which is what we're solving for. Now with that, we know that we can just use regular trig because we have an angle, a side, and a right angle. And so I'm just going to label my sides. This is going to be across from this is my opposite. Across from my 90 is my hypotenuse. So since I have opposite and hypotenuse, this is going to be a sine problem. So this is going to be sine of 47 equals opposite over hypotenuse. In this case, h is my opposite and 191.14, my hypotenuse. Now since I'm dividing by 191.14, I want to multiply by it to get rid of it. Okay, these cancel. And I'm simply left with h equals, I just threw that on the other side, this times this. So that's going to be 191.14 times sine of 47. Okay, and that is equal to 139.79 feet, which seems reasonable for the height of the Eiffel Tower. Though it might be taller, who knows. All right, there we go. Going on to the next page. A construction worker needs to determine if a wall he built is at a right angle. He marks a point 3 feet from the corner on one wall and then another 0.4 feet from the corner at the same height on the other wall. He finds that the straight line distance between these 2 points is 5 feet 7 inches. At what angles do the walls meet? Obviously, we want a right angle. We want the answer to be 90 degrees, but I'm not sure it is. I think it's going to be a lot bigger. So let's say, I think it's going to be a picture that looks something like, we'll go with 3 feet, a little wider here, longer, 4 feet, and then we've got 5'7" here. We're trying to figure out what this angle is right here. Well, first of all, we need to convert 5 feet 7 inches into a decimal. And so 5 feet and 7 inches is going to be 5 plus whatever 7 divided by 12 is. Well, that's going to be 5.583. So 7 divided by 12 as a decimal is 0.583. So I'm going to mark that right here, 5.583. And it kind of makes sense that this angle is going to be bigger than 90, right? Because this is bigger than 5, which we want to be 90. And so it's making the two sides 3 and 4 kind of go out wider to make sure it hits the ends of this length right here, if that makes sense. All right, so I'm going to label my sides as A, B, and C. And of course, across from those are the lowercase versions. We certainly remember that. And you should see this as a law of cosines problem because we have all 3 sides and we're looking for the angle. And what angle are we looking for? We're looking for uppercase A. So that means I'm going to use the A formula. And just as a reminder, that's A squared equals B squared plus C squared minus 2BC cosine A. And now it's really just a matter of plugging into this equation. So we're going to do that now. I'm going to have 5.583 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 cosine of A. And I just put an A because that's what we're looking for. We don't actually have a number for it yet. All right, so doing that math out, I do put that in my calculator and get 31.17. And 4 squared plus 3 squared is 25. 2 times 4 times 3 is going to give me a 24, so that's going to be minus 24 cosine A. So all I have done is that math, and that math, and I plopped it down. All right, now solving for cosine A, I've got to get this 25 on the other side, so I'm going to subtract 25. And that's going to give me 6.17 is equal to negative 24 cosine A. Going to divide by that negative 24. And you should get a decimal, and negatives are fine as well. It's going to be a negative 0.257 equals cosine A. And then I need to take the inverse of both sides, so that's going to be cosine inverse of negative 0.257 equals A, or I'm just going to be a little bit fancier and write the measure of angle A. And I just do that in my calculator, right? Press second and then press cosine and then put in that negative 0.257. And that just leaves me with my angle. And it should be around 90, but it should be a little bit bigger. In fact, I get 104.9 degrees, which means this is pretty darn far off from being a right angle. Which makes sense because that should be a 5 if we want a right angle. And that's quite a bit bigger. All right, number 4. The area of a sector of a circle with radius 4 inches is 4 pi over 3 inches squared. What's the measure of the central angle in radians? Well, area is going to be 1/2 r squared theta. That's something that we derived in our units. And now I'm just going to plug straight in. I know that my area is 4 pi over 3. You don't need to include your units. So that's going to be 4 pi over 3. 1/2. Now my r is given to me as 4, so I'm going to have 4 squared theta. Okay, now simplifying this, let's simplify 4 squared, and that's 16. So I just rewrite everything except I want to write 4 squared as 16. Then I want to say what's half of 16? Well, of course, half of 16 is 8. So I have 4 pi over 3 equals 8 theta. And you could either divide by 8 or multiply by 1/8, whatever you prefer. I'm going to multiply by 1/8 because I can. Okay, my 1/8 and my 8s cancel, and I'm just left with plain old theta over here. And then I know 1 times 4 pi is 4 pi, and then 8 times 3 is going to be 24. So I get that theta is equal to 4 pi over 24, and I'm almost there. I need to do what? Yeah, I need to reduce that, so I can divide the numerator by 4 and the denominator by 4, and I get pi over 6. This is actually a problem that you could check your answer on. You could kind of go right to the beginning here and plug in theta, which is pi over 6, and then plug in 4 for r, and make sure you do get 4 pi over 3. All right, moving forward. Number 5, if cosecant theta is negative 5 over 4 and theta is between 3 pi over 2 and 2 pi, find the exact values in reduced form. Well, let's go ahead and do cotangent theta first, but honestly what we really need to do is draw a picture so we know where it's located. And if we have 3 pi over 2 and 2 pi, that's kind of where we're between. We're going to have a 3 pi over 2 here and a 2 pi here. So we know we're in the 4th quadrant. We also know that cosecant is the reciprocal of sine, and if sine is opposite over hypotenuse, then this is going to be hypotenuse over opposite. So I'm going to go ahead and I'm going to draw this in. So I know that my hypotenuse is going to be 5, and I know my opposite, which is across from the angle, is going to be 4. And that comes from h being negative 5 or 5 and opposite being 4. And if you're saying, hey, Ms. Sorensen, we've got to deal with the negatives, I think you're totally right, but I want to do that kind of once we've filled in our triangle. All right, if the hypotenuse is 5 here and the leg is 4, we should know the 3, 4, 5 triangle, which is right here. The other one you should know is the 5, 12, 13 triangle. Hint, hint, nudge, nudge, wink, wink. All right, so now that we have our sides labeled, we do have to deal with the fact that we have a negative here and figure out where it goes. Well, if we're going to go right here and down 4, which one has the negative? Well, of course, it's the 4 because you're going down 4. And our hypotenuse is always going to be positive. It's always that length. All right, so now we need to find cotangent theta. And if you'd like, you can go ahead and you can label your sides. This is going to be your opposite. This is going to be your adjacent. And this is going to be your hypotenuse. And cotangent is the reciprocal of tan, and tangent is opposite over adjacent. So of course, cotangent is going to be adjacent over opposite. When I just said that, I said adjacent over opposite, so that's going to be 3 over negative 4. Now, it certainly does not matter where you put the negative as long as your answer is negative. All right, next problem here is sine of 2 theta, and we should remember that sine of 2 theta is 2 sine theta and then cosine theta. All right, so what does that give us? Well, first we need to find what sine of theta is and what cosine of theta is. And I'm going to go back to my picture right above here, and I know sine is opposite over hypotenuse. In this case, that's a negative 4 over 5. Right, I'm looking at, in this case, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and so that's going to be adjacent over hypotenuse is 3 over 5. Wow, look at how beautiful that is. All right, so filling that into our problem here, we've got 2, and then my sine theta is this. Okay, so I'm going to have negative 4 over 5. And then my cosine of theta is 3 over 5, so I'm going to have 3 over 5 here. And then I like to rewrite my 2 as a 2 over 1, just helps me remember how to multiply my fractions. And to do this, I'm going to multiply straight across. I get 2 times negative 4 times 3, which I get negative 24. And then 1 times 5 is, of course, 25. Now, we did learn how to check our answers here, and you are not required to do this, but heck fire, you know, it's your final exam. It's worth quite a bit of points. So let's do a quick check step. Like I said, you don't have to do this, but I like to do it. So if we have a 3, a 4, and a 5, and yes, this is negative, I can just go ahead and do theta equals cosine inverse of 3 over 5. And you could have done tan inverse or sine inverse, but remember to keep it positive. I get theta equals 53.13 degrees, which really means that because I'm in the 4th quadrant, I have 360 minus 53.13 degrees, which is going to give me 306.87. So if that's my theta, then 2 theta is going to be 613.74. And then I'm going to take sine of that, because this problem says do sine of 2 theta. So I'm taking that, and I get exactly negative 0.96. Now if I do this problem out, negative 24 over 25, that is a negative 0.96. So you can see that I've got my answer correct. All right, last one before we move on to a different video. Cosine of theta over 2. Okay, well, first of all, we really should figure out if this is going to be positive or negative, because if you recall, the formula is cosine theta equals plus or minus the square root of 1 plus cosine theta over 2. And I have to choose if it's plus or minus. Well, guess what? We've already found what theta is in this problem. We know that theta is equal to 306.87. So theta over 2 is going to be equal to 153.435. Well, that still doesn't help us unless we look at the picture. Where is 153? Roughly it's about here, right? So we're talking about this angle right here being theta over 2. Okay. Well, we're talking about cosine, and is cosine positive or negative in the second quadrant? Well, you could certainly look at your unit circle to figure that out, or you could say all students take calculus and know that the only thing that's positive in the second quadrant is sine. So that means that cosine is negative in the second quadrant. So that means we're going to choose the negative version right here. Okay, so theta over 2 is in the second quadrant, which means that cosine theta over 2 is negative. Forgot the n. It's key to writing negative. All right, so moving forward with this, we need to find what cosine theta is. And I'm just going to kind of do that over here. I know cosine theta is adjacent over hypotenuse, right? And if you look over here, I've already found it. It's 3 over 5. So, and if you forgot how to do that, you remember you have to draw your triangle, find your adjacent, find your hypotenuse. All right, so plugging into that, I get cosine theta equals negative, don't forget that, 1 plus 3 over 5 divided by 2. And this whole thing is under the square root, like that. So I'm going to pull this off to the side and I'm going to do that math. I can rewrite 1 as 5 over 5, and then I'm going to add the 3 over 5. So that's going to give me 8 over 5. So that's what goes here. So that's going to be cosine theta over 2. Sorry, I forgot that each time. Is going to be equal to the square root of 8 over 5 over 2. Well, if I'm dividing by 2, that's the same thing as multiplying by a half. So I'm just going to multiply this by a half, and I get 8 over 10. Well, what does 8 over 10 reduce to? It reduces to 4 over 5. So I really have that cosine of theta over 2 is equal to negative the square root of square root of 4 over 5. Well, when we do the square root, we need to do the square root of the numerator and the denominator. So this is really going to give us negative 2 divided by root 5, right? Because we know that the square root of 4 is 2, and you have to carry that negative through. That's a funky looking negative. You can put it in the numerator, the denominator, outside, doesn't matter. All right, so now we need to rationalize this by multiplying by root 5 over root 5. Well, that's going to give us a negative 2 root 5 in the numerator. And then that's going to give us a root 5 times root 5 in the denominator, which is 25. So our final answer is negative 2 root 5 over, but that should have just be 5. That's my bad, because root 5 times root 5 is a root 25, which is, of course, 5. That's my apologies. All right, there we go. That's our answer.